Okay, today, Module 1, Lesson 19, Lesson 19, Module 1. It's really going to be a second day of looking at rearranging formulas. And really, what we're doing in this lesson is just picking a variable and then using everything that we learned so far to move things around and solve for that variable. So these are sort of generic equations. And in class, we've already looked at numbers 1, 2, 3, 4, and I even assigned some other ones. I assigned some other ones to be done in class, which I believe were 9, 10, and 13. We may not have gotten to all of those, but today I'm going to do 3 additional ones so that you can continue to see, what we're really trying to do. And so here we go. I'm going to get right to looking at, of this set that you're looking at here in your Eureka Math workbook, Lesson 19, Module 1, we're going to continue to forge forward in practicing solving for particular variables. And so let's begin. Okay, so I'm going to select 5, 8, and 9. I know 9 we didn't get to, so that's one of the reasons why I want to do that. And so let's take a look at what these look like here. So I'm going to take my time, try to keep this video relatively short. And so here we go. Stop the video when you have to. Like I said, I'm going to move forward at a pretty good pace. Let's start by solving for x in number 5. So the first thing is we want to make sure that we understand that let's identify where x is at. It's right there. So my first thing is I want to get this by itself. So we want to isolate this letter. And the first thing I notice is I'm going to add 7 to both sides. That goes to 0, and I'm left with x over 5 is equal to 2q plus 7. Now, I can't add those together. They're not like terms. They are not like terms. So my last step then is to simply isolate x, continue to isolate x by doing the opposite, what you're doing here, divided by 5, which is multiplying by 5. That reduces, and your final answer, x is equal to, you can distribute through, and your answer is 10q plus 35. In fact, this problem was, I believe, the exit ticket that we looked at the other day. There it is. Okay, right to number 8. Let's go to number 8, and again, we're solving for x. So let's find x. Where's x at? It's right there. We need to get that by itself. And so we have some things going on here, and I noticed that this one, I noticed something. I can write this as 1, 4d over 1. And then I can consider this as a proportion. Now that may help me down the road. I'm going to look at this as a proportion. And we know that with proportions, we can cross multiply. And that's what I'm going to do first. So 3ax plus 2b is equal to c times 4d, or 4dc. Keep in mind, all along, you're trying to get x by itself. So the idea is sometimes you can use past knowledge like proportions, cross multiplying, to help us simplify. Now, one of the other things we could have done is just multiply both sides by c. That's another way we could have done that. Nevertheless, we get the same second step. We get rid of c in the fraction. Here we go. Let's solve by, first of all, subtracting 2b on both sides. And then since I am solving for x, I'm going to divide by 3a on both sides. And believe it or not, x is equal to 4dc minus 2b all over 3a. And that's the answer. That's the answer. There we go. There's a rhythm to this, and there's things that we've already known, which is always what we do on one side, we do on the other. What we do on one side, we do the other. And then obviously the distributive property. proportions. What we do on one side, we do on the other. There is a rhythm to this, things that we've already learned that we're utilizing in these generic equations. Number 9, the last one, we're going to solve for M. So this is another one where I'm going to go ahead and I'm going to do this one differently. I'm actually going to take this one, instead of setting up a proportion, which I could do, I'm actually going to look at this as multiply both sides by M plus N. So I'm going to take both sides, multiply by M plus N. That reduces, and I'm going to have M plus N times T is equal to MS. Now remember, we're solving for M. So I'm going to have to distribute this T in and here. So I get MT plus NT. Pause the video if you need to. But this should be self-evident. We've done this before. Keep in mind also, what are you trying to solve for? Where I'm trying to solve for M. So I've got to get these together. So I'm going to move this over by subtracting MT on both sides. That leaves me with NT over here. And on the other side, I still have the the MS minus the MT. This is where we're going to utilize what we learned a couple days ago. We're going to factor out an M. So NT is equal to, I'm going to factor out an M, bring it out, and I get M. And what's left is the S minus the T. And then finally, my last step. So that factoring out, dividing out helps us because now there's M by itself. The last step is to divide by S minus T. And believe it or not, this is your final answer. This is M. There you go. That's M. And so as we look to moving forward here, we're going to do some more problems, and I'm going to go ahead and let the directions in class directions dictate from the problem set from lesson 19. You're going to be asked to go back to that, and some of these we're going to be practice problems for class. Hope that helped. This is the second day of work on lesson 19. Pause the video, stop it, rewind, whatever you got to do. Good luck, and talk to you soon.